Okay, let's prove this approximation. So note that we used this formula, right? So then what is x bar? X bar is 1 over n I equal to s xi, which is I equal to ut. So that's the definition of xi. So that means 1 over n and d. So that means variance hat p hat here, right? So let's write it here. So this one, okay, is 1 over n times x bar square. So that means 1 over 1 n over n d square, right? Times 1 minus f, 1 minus n over n, times s e square, which is which is n minus 1 I equal s. Okay, this one, right? So that is sd yi minus y bar d square. Okay. So 1 over. Basically, you can see that that is becomes n d square 1 minus n over n minus 1 sd yi minus y bar d. So that's the same algebra, and then you can approximate it this one as so this one as nd over nd minus 1. So you can write it this way. So then it becomes nd 1 minus n over n 1 over nd minus 1 equal sd yi minus y bar d square. So that proves the this result. Okay. Okay. So now let's get back to the boat owner survey example and suppose that we have a realized sample in the following table. The sample size is so the total sample size is the 1500, right? And with two domains based on the type of boat. So this is the first domain is the large, right? Large boat, something like that. And in addition, we have information about the number of children for each participant of the survey. So from the survey, suppose that we are interested in estimating the following three parameters. The first parameter is the proportion of large motorboat owners who have children. So among the boat owners, how many of them are have children? What percentage? The second one is the average number of children from domain 1. And third one is the total number of children whose parents register for large motorboat. So that is a domain total. Okay. So for theta 1, it is a proportion of those with children among domain 1. So among domain 1, Okay, among domain 1, we have these many who has children. So that is the total number is 396. So the theta is 396 divided by 472. So about 30% 0.9%, 30.9% of them has children. Okay. So what about the variance? So the variance, basically, the proportion itself is also another special case of the sample mean, right? Domain mean, and we're gonna use this domain mean variance formula. But now the trick now one thing to note is that for this one, yi here is either 1 or 0 for the proportion, right? So if it's have a children, then it's 1. Doesn't have a children, it's 0. So in that case, this one is actually y body 1 minus y body, approximately. That is the proportion, right? So that's actually, you can say that this is you can say PD p hat d minus p hat d, something like that. So for proportion, we can make this sample variance to be p times 1 minus p, something like that. So that's basically the formula here. So we have a sample size is 472 here, and then proportion, this proportion can go inside to get the variance formula. So to be rigorous, we should have this one, but we just ignore this to be equal to 1. For the second parameter, estimating theta 2, this is basically domain mean. So ND is still the same. ND is 472, but now the y's are different. The y here is that okay, the yi can be individual number of children. So it can be 1, 2, 3, right, or even 8. So it's basically a number of children. Yi is number of children. So the summation here. So how to compute this summation? So basically, you can see that this summation is. So how do you understand that this frequency table? This is basically count, right? So these are the count, head count. So among 472, we have 76 people having no children, 139 people having 1 children, something like that. So summation of the DYI should be then equal to 0 times 76 plus 1 times 139 plus 2 times 166. Right? And 3 times 63, blah blah blah, and 8 times 1. So that is the summation. Okay, so that gives the this number. So that is actually, if you do that, you will end up getting 787 in the numerator, and denominator is 472. So the answer is 1.67 is a average number of children among domain 1. Okay, and then for variance estimation, we'll use this formula, and we'll do the same computation. So basically, this summation, basically you can just divide it by you just apply it separately for each count. Okay, so basically, how many 76 times 0 minus y bar d plus, okay, so this one square, and then 139 times 1 minus y bar d square, blah blah blah. And how many? 1 times 8. Okay, 1 times 8 minus y bar d, something like that. Okay, and then nd is 472. Okay, for the total estimation, you note that this is just the summation, and so the total estimator is so summation of UI. So how you can compute UI out of this? Well, basically UI is what? UI is this one, right? So the table of UI, okay, UI can take from 0, 1, 2, 8. And then how many of them? The count for UI should be 76 plus, because among 1,500 sample size, UI equals 0 can be either y equals 0 or it's outside the domain. So that is either 76 or outside the domain, which is 1028. 1028. Okay. Others just for other domains. For others, it's just the same. Okay, same count. So 139, 139, 166, 63, blah blah blah, and 1. Okay. So 1104. Okay. So that's the sample. So sample of UIs, and so U bar should be summation of this. So that is something like 0 times 1104, so 4, plus 1 times 139. Oops, no, I don't have a space, but U bar is summation sample UI divided by n, so that is 150, 1500, and then 0 times 4 plus 1 times 139 plus 8 times 1, which is basically, so this number. So that is 209 point, oops, sorry. I don't have the number, I guess. 1.52, something like that. Okay, sorry, 0.5246. So you can compute this. So that's the sample mean, 0.5026646. Okay. And the variance, so that's, you can obtain this, and then total, we use this formula, right? We use this formula. So this one should be small. So this one should be small as u square. Sample variance of u. So su square should be 1 over n8. Okay. So let's use definition. Minus 1 ui minus u bar, something like that. So that's 1 over 5, 1500. Okay, so that this one should be something like 4 times 0 minus u bar square plus 139 times 1 minus u bar square, blah blah, and 1 times a minus u bar square, which is 1.0394. So that's comes here, and then you obtain the variance. Okay.